Hello viewers and welcome to Curiosity Square. The objective of this lesson is to make students able to count the number of trailing zeros for large numbers. So let's begin with the definition and some examples of trailing zeros. Trailing means behind. So I hope you guys can guess what trailing zeros actually means. It refers to a sequence of zeros in a number such that no other digits follow behind the last zero. In the first example, the number 1200. You can see the number ends with two zeros. You can say there are two trailing zeros for number 1200. Next we have 108,000 ends with three zeros. The zero between 1 and 8 is not counted because the number 8 follows behind that zero. Hence we can say this number has three trailing zeros. Let's look at the number 600 million and 300,000. So if someone asks you how many trailing zeros are there, then we count and we must say there are 5 trailing zeros. The two extra zeros between 6 and 3 are not counted. Let's look at our problem. Here we have to find the number of trailing zeros for 2017 factorial. This exclamation mark refers to the factorial function. It basically means 2017 multiplied by 2016, multiplied by 2015, and so on until multiplied by 3, by 2, and finally by 1. No doubt this is a huge number, and even a normal scientific calculator cannot calculate this. It's very likely to give up on you. But by using computer, you could calculate it. But it is very unlikely any student is going to get the answer because in such type of competitive exams, calculators are not allowed during the calculation process. The actual number comes up to 5,792 digits. This huge chunk of trailing zeros attached to it are highlighted in red. So the question is how many of them are there? Please pause the video here if you like to give this problem a try. And when you are ready, keep watching the video and I will explain the trick to this type of problems. I hope some of you are able to get the solution. So one strategy that we can employ to solve this problem is to first look at an easier case of this problem. Let's look at 10 factorial. 10 multiplied by 9 by 8 all the way to 1. We know from our basic maths, if you multiply anything by 10, you will get a trailing 0. So 10 factorial will have at least a trailing 0. But is that it? If we look closer, 2 multiplied by 5 will also give us 10. So 10 factorial actually have 2 trailing zeros. The problem is then reduced to how many factors of 2's and 5's are there in 2017 factorial. To further simplify the problem, we can ignore the factor of 2's because they just occur far more commonly than the 5's. And then finally we are just looking for the factors of 5's. So let's start our calculation. Since there is a multiple of 5 in every 5 numbers, we can just divide 2017 by 5 and round it down, or take the integral part, or you can say the greatest integer of it, which will round the number down to the nearest integer. 2017 divided by 5 gives us 403.4, whose integral part is 403. All this we did without using calculators. So the answer is 403 trailing zeros. 403 would be wrong. If you look closely, you can see in every 5 multiples of 5, there is a multiple of 25, and 25 is square of 5. So it has 2 factors of 5 in it. This gives rise to 2 trailing zeros when multiplied by 4. So how can you calculate how many multiples of 25 are there in 2017 factorial? So if we divide 403 by 5 and take the integral part or round it down, it tells us that there are 80 multiples of 25 which contribute an extra 0. But are we done? No, not yet. 125 or 5 cube which generates 3 trailing zeros when multiplied by 8, and 625 or 5 power 4 will generate 4 trailing zeros when multiplied by 16. And if you are watching this video in the year 3125, there's a chance you must consider 5 to the power of 5, that is 3125, which gives 5 trailing zeros when multiplied by 32. So let's look at the final answer. In total, the multiples of 5 produce 403 trailing zeros, but multiples of 25 produce additional 80 zeros, as 25 times 4 is 100, which has 2 trailing zeros, and we have calculated only 1 zero for each 25 in our earlier calculation of 403. So we will add 80 to our earlier calculation 403. And again, the multiples of 125 produce extra 16 more zeros. As you can see, 125 times 8 is equal to 1000, which has 3 trailing zeros. But we have calculated only twice in our previous calculations, once in 403 and once in 80. So 16 more zeros will be added. And finally, the multiples of 625 will add 3 more trailing zeros on the top of all that. That gives us to a total of 502 trailing zeros. So there we have it. 2017 factorial has 502 trailing zeros. I hope you enjoyed this video. So thanks for watching. Please give this video a like if you get to know something new today. Please subscribe to get more videos on mathematical problem solving strategies and interesting fun puzzles. And you can catch me on Instagram for more life-changing facts and motivational quotes. There are links in the video description. As always, thanks for watching and thanks for your support.